Alrighty guys, this lesson is adding, subtracting, and multiplying monomials. It is for February 14th, so happy Valentine's Day. I have this top portion already filled in. You should have gone over this in class. So a monomial is a number, variable, or it's a product of numbers and variables. These are some examples here. So it's a term, one term. There's no adding or subtracting. There's a coefficient, there's a variable, exponents possibly. Today we're focusing on like terms. In order to be like terms, the monomials have to have the same variables and same exponents. Okay, so it says that right here. Same variable, same exponent. So to add or subtract, we just combine like terms. And the important part is we're not changing the variable or the exponent. So we're really just adding or subtracting the coefficient. All right, so what does that mean? Remember, the coefficient is the number in front. Number one here, I can see that these are like terms because they both have an x and they both have a power of 1. If there's no exponent there, it's an invisible 1. So because they're like terms, all I have to do is combine the coefficients. So this is 17x minus 25x. So I'm doing 17 minus 25, which is what? Negative 8. So negative 8x. That's it. Okay. I didn't make it x squared. The x's didn't go away. I just brought it down. Okay, so I'm focusing on the numbers in front. Okay, number 2. Again, I notice these are like terms because they both have y's and both of the y's are squared. So I look at my negative 23 and my positive 6. I combine those and my y squared stays the same. So negative 23 plus 6 ends up being negative 17. Y squared. Okay, so I feel like you guys are going to catch on to this pretty quickly. Combining like terms. That's pretty much it. Let me see if there's anything that really stands out to me. We can see number 3 are like terms. A cubed BC. A cubed BC. So at this point, we would combine negative 15 and positive 6. All right. 4 as well. X squared Y. X squared Y. Remember, there's an invisible 1 here. So in this case, it's 38 minus 1, which gives us 37. X squared Y. So nothing changes there with my variables and exponents. Okay, let's find something that's not like terms. Take a look at number 5. I have AB and AC. Yes, they both have A in common, but the individual terms do not have the same variables. One's AB, one's AC. So we can't combine any like terms here. There's no like terms. So that's it. 2AB plus 9AC. Okay. Number 6, they both have M and N. So we would combine negative 8 and 9. Alrighty, let's take a look at some more. My videos can only be 15 minutes, so I'm not going to do all of these. Number 7, they are like terms, so have fun with that. Common denominator it. I don't really have time, and I don't really feel like it, to be honest. Okay, let's take a look at number 9. We can have, this is a polynomial. There's multiple terms, right? Multiple terms. We can have different variables in the same expression, as we see here. All right, well, I combine my y's with y's and I combine my z's with z's. Oh my gosh, I'm so tongue twisted right now. 3y and 3y, 9z and negative 3z. Please make sure you pay attention to the signs in the front. A common mistake while combining 9z and 3z would be to put 12. Okay, but it's 9 minus 3. Okay, so there's a negative in front, minus, negative, same thing. So 3y plus 4y here is going to give me 7y. 9z minus 3z is 6z. So 7y minus, no, I'm wrong. It's plus. It's plus. Here I am. See, lesson learned. Check your signs. 3 plus 4 is 7. 9 minus 3 is positive 6. So 7y plus 6z. Okay. Okay, let's keep on looking. Number 10, I can see I have two like terms, and then I have an 8a that's all by itself, nothing to combine it with. If I can't combine it, I just bring it down. I can bring it down first, I can bring it down last. The order doesn't really matter as long as our signs are correct. So that's a positive 8a. And then I have 12b minus 10b. So 12 minus 10 is a positive 2b. Okay. These problems are they feel strange because we're not used to really having an answer that looks like it's unfinished. These are going to look and feel unfinished, okay? But we're not actually solving, we're just simplifying, okay? We're not solving. I'm not solving for A, I'm not solving for B. We are simply combining like terms, okay? What else? Down here, we see that the problems aren't really set up for us. They're more like in a sentence. Find the sum. Well, you guys know sum means adding. So I'm combining these two, right? So 16y squared plus negative 5y squared. Same thing as 16 minus 5, yes? So this would just be 11y squared. Okay? This next one says find the difference. Well, I know difference means subtract. So I'm subtracting 10x squared y minus 2x squared y. They are like terms because they have the same variables and the same exponents. So you can take it from there. Subtract, we're subtracting 10 and 2. All right. Okay, subtract 9a from negative 15a. Oh, we've seen and heard this before. These ones are like the turnaround. Remember, if we're subtracting something from something, then this negative 15a needs to come first and then minus the 9a. All right, and you guys can simplify that. And then here, same thing, from 9 CD squared, oh, battery's low, subtract to negative 2 CD squared. This is not a turnaround one because we're subtracting the way it's worded, right? We're this one, it's all kinds of flip-flopped, but we're taking 9 CD squared and subtracting, ooh, careful, it almost got me. We're subtracting negative 2 CD squared. What do we notice right here in the middle? We have minus a negative, right? We're subtracting a negative. So you guys ask yourselves, figure it out. What are we going to do there? Okay, opposite of negative 2 and then combine. All right, so that is the notes for adding and subtracting. We're combining like terms. We're looking for same variable, same exponent. All right, and we just add or subtract the coefficients. Flip it over, and I'm going to introduce you to the product rule. Well, I'm not, Miss Barrett is, but if you need a refresher or if you're absent. To multiply monomials, we're going to use the product rule. The product rule tells us, it's very interesting, when we multiply x to the a times x to the b, we are actually going to add our exponents. Okay, x to the power of a plus b. So why is that? Well, let's take a look here. X squared, if I broke this up, x squared is x times itself, right? And I'm multiplying that by, so that's 2 of them. I'm multiplying that by x cubed, which is x times itself, but 3 times. How many x's is that? Not 6, because looking at this, our brains are going to want to do 2 times 6 because we see this multiplication symbol here. But x squared, that's x times x cubed is x times x times x. That's going to give us x to the 5th. All right. Now, I'm not expecting you to expand it out like this every single time, but I want you to understand where this rule is coming from. Why do we add the exponents? Okay, a to the 9th times a. We have an invisible exponent. It's a 1. If you don't see the exponent there, it's a 1. So this is a to the 9th. I'm just going to list all these out. A. How many? What number am I on? 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's one more. So I don't multiply 9 times 1. There's 9 A's times 1A. That's A to the 10th. Okay, 9 plus 1 is 10. Lastly, I don't feel like listing all these out. W to the 7th times W to the 4th, I'm going to add, and I should get W to the 11th. Okay? So let's put this all together. What happens if we have examples with coefficients? We are going to multiply the coefficients. That's our big numbers. Simplify the variables with the product rule. Or as I like to say, multiply the coefficients, add the exponents. If big words scare you, I like to say, multiply the big numbers, add the little numbers. Okay? Multiply the big numbers, add the little numbers. Okie dokie, here we go. So our coefficients, 4 and 3, we're going to multiply those like normal. 4 times 3 is 12. Now, you have to make sure that your base is the same. When I say base, I mean your variable. These are both x's. They have to both be x's in order to add our exponents. They are, okay, I mean either both x's, both y's, b's, a's, whatever you want. 7 and 5, not 7, I just said the answer. 2 and 5 make 7. Okay, so 12x to the 7th. All right, let's try another one. Multiplying our coefficients, adding our exponents. 3 and 5 is 15, x to the 8th. 6 plus 2 is 8. If I get one of these wrong and I don't notice, I'm sorry. I'm a little bit tired. This is like my 3rd video in a row. Okay. I feel like we got that down. Let's look at some more difficult ones, shall we? Okay, here I have -4 and 3. I have A's and I have B's. We're going to do one at a time. Okay, so -4 and 3 is -12. Also, draw in all of your invisible ones. If there's not an exponent, draw an invisible one. A to the 3rd, A squared. That's going to give me A to the 5th. B to the 1st, B to the 5th, B to the 6th. Okay, so that's -12, A to the 5th, B to the 6th. Multiply our big numbers, add our little numbers. Multiply our coefficients, add our exponents. Okay, I only have a couple more minutes here. Sometimes they don't put parentheses on them. If the parentheses make you feel more comfortable, you can put them on. I kind of like it better with parentheses myself. I don't know why. So -7 and -4 is positive 28. I'm going to draw my invisible one there on the R. P to the 9th, P squared. That's going to give me P to the 11th. Q to the 3rd, Q to the 6th is Q to the 9th. R to the 1st, R to the 4th, R to the 5th. Okay, is there anything on here that looks too crazy for us? Like I said, I kind of like putting those parentheses in. Like this one hurts my brain a little bit if I don't have the parentheses. So, I don't know. I guess it's just preference. 6 times 7 is 42. I'm going to put all my invisible ones. M to the 1st, M to the 2nd is M to the 3rd. N to the 1st, N to the 4th is N to the 5th. Okay. This one here just has a random -4 on the outside. Same thing. Multiply our coefficients. So -4 and -5 is going to be 20. There's invisible one here, invisible one here. So 20 R to the 5th, S to the 3rd. All right, down here we're putting it all together. Think of PEMDAS here. PEMDAS. We need to multiply, then add, right? So when you multiply these, you should be getting some like terms, and then you can apply combining like terms from the first page. Okay, I think I have time to do one of these. Which one? I don't know. Let's do a subtraction, because usually students, I don't know. -5 and -3 is 15. Put all your invisible ones. Invisible 1, invisible 1. C to the 5th, D squared. Minus 7 and 2 is 14. C to the 5th, D squared. Oh, would you look at that? I have like terms. If they're not like terms, I leave it like that. But these ones are. 15 minus 14 is 1. You can put the 1 there or not. C to the 5th, D squared. Alrighty, so that is adding, subtracting, multiplying monomials in a nutshell. Bye!